Gabriel Valley Linux Users Group. The first thing we're going to do is let Bobby say a few things about OpenX because they've been so incredibly gracious to host us and allow us to meet here not just tonight, but many, many, many times. So I'm just going to keep going about how great OpenX is until he gives me the signal that he's ready to talk. So OpenX is the company we're here, and they're gracious enough to bring us into their building and allow us pizza and possibly not pizza depending on the quantum state. And some of you got that explanation when you walked in, but this is OpenX. They feed us, they let us present here, and they are amazing.
We make awesome programmatic marketplaces.
And they make awesome programmatic marketplaces. Obviously.
What else do you do in the building?
Are you ready?
Yeah, I'm ready now.
He's ready.
So, my name is Bobby. I'm a release engineer here at OpenX. Show of hands, who else works at OpenX? Ask that guy with the green hat. That's Drew, and our buddy with the OpenX t-shirt. That's awesome. That's Eddie. If you want to hear more about us, that's awesome. That's who to talk to. I am on the tech side of things, so I have gone to our official website to read off our about page so I don't screw this up. And now my phone locked. Here we go. OpenX creates quality programmatic advertising markets that drive superior monetization for publishers and optimal value for brands, etc., etc. Our robust technology infrastructure ensures full reliability for ad formats across all digital formats. That's recently updated, so I'm glad I double checked. We like to be part of. Thank you. Thanks, man. We like to be part of the community. That's why we host these things. You notice that we frequently attend these as well because we like them, and we like pancakes. And who else? Besides you guys like Linux and pancakes. About everybody in San Gabriel Valley Live. So I just want to say thank you for coming. Thank you for being a part of it. These meetings don't happen without people dropping in and seeing what it's about. So without further ado, Linux in the news.
Linux in the news, but I do have one bit of stuff for you. He's wearing the OpenSUSE hat in the back so you can harass him about not using Ubuntu. So you know, he's asking for it.
Use OpenSUSE. It's free. Is it free? It's free.
So,
as free
as we traditionally start our meetings,
wow.
We traditionally start our meetings with Linux in the news, and you guys have to provide the Linux in the news because I fell asleep at my computer today and thus did not finish my Google search. So, does anybody have any great news about Linux for this month or at any point in time? Yeah, go ahead.
This is so breaking, I don't even know what I'm about to say.
Great.
I just stumbled across a headline, and the headline alone is pretty awesome. Mozilla starts $500,000 fund to help open source projects with security audits.
Wow.
Okay, so for those of you who couldn't hear because you're sitting behind Richard, apparently Mozilla has started a $500,000 fund to help open source projects do security audits. Is that correct?
Yeah, they're hiring security specialists who will do penetration testing and other services.
Cool. So they're hiring people to help attack your programs and make sure they're secure. Because as we all know, security is one of those things that can be good and can be bad in open source projects, depending on how security conscious the engineers are. And somebody did a talk on security here. Was that you? Did you do a talk on security?
Not here. I did.
Wasn't it like Carlos with the DNS set?
Yeah.
No. Before that.
Before that.
There was somebody who did an intro to security stuff, and I thought it was you, but maybe that was something else. Did you do a talk at LUG? Or at Scale?
I did a cryptography on this.
That was the one. He did a cryptography talk, which is part of security.
At Scale.
Scale
At Scale, yes.
And also
So-
at Love.
Yeah. So anyway, back to Linux in the news. Any others?
There's a new
You
release
had one?
of Tails out.
Say that again?
There's a new release of Tails out.
Okay. There's a new release of Tails. Can you explain more?
Well, I just got the email earlier this week. So you're looking for news. I think the version number was 2.4.
Tails 2.4 is available.
Yeah, it's a Debian spinoff that has a whole bunch of security tools like pre-installed.
Okay, so Tails 2.4, a Debian variant for security analysis, has released their 2.4 version. Is that correct?
Yeah.
Cool. Carlos, you had something.
Oh, Tuesday, Fedora 24 comes out.
Woo! Fedora 24 comes out on Tuesday.
Or gets pushed back 3 more weeks.
Any other news?
Google won their case against Oracle.
Google won their case against Oracle.
The Java APIs?
Yes.
Can you summarize the case?
Probably not really. It was over the APIs, and there's like some like discussion about what that means with dual license projects and what it means to please.
Okay, Oracle had sued Google over the API setting copyright infringement for their Java equivalent. The judge and jury decided fair use, which was their defense, was acceptable, so no copyright infringement ensued. It was on Slashdot.
So, for those of you in the back, since everybody is facing this way, Oracle was suing Google because Google was implementing their own version of Java, meeting Oracle's APIs, so they sued them. But the judge and jury ruled fair use in Google's favor, so Google was allowed to create their own Java variant, I imagine for Android? Or
Yes,
just in general?
and I'm sure
So,
it'll be
for
appealed,
Android.
but at least for now.
Well, it's on. That was what, the second appeal or something? No, that was the second lawsuit in a series. Because they lost the first one on appeal.
Okay?
Given that we live and die on being able to sort of, re-implement APIs, that's pretty big.
Yes.
That kind of is what keeps us alive, so.
So, hooray for open source.
Yay.
Any other Linux open source in the news? Go ahead.
Somewhat related Linux news. OwnCloud, a big portion of people who were working for the company behind OwnCloud left OwnCloud and started a new project called NextCloud.
So OwnCloud has now lost some of their people to a new project called NextCloud.
It's worse than that. Like they've actually lost funding and had to shut down part of
The US
let people go.
The U.S. branch, the OwnCloud Inc. had to be shut down, but OwnCloud, the German company, is still around.
But NextCloud is actually founded by the person that's created OwnCloud, so there's some weight behind that work.
Cool. Did you all catch that? Yes? I'm wondering how much I should parrot back to you guys, because
Or nobody
you're
cares.
all facing this way. So some of you might have trouble hearing, but also the people in the front are hearing both. So anything else that we want to announce for the LUG? There is a GitHub conference coming up, and the people at GitHub have given us a code for $150 off?
Yes.
$150 off. So it's posted on Meetup, and you can find it there. This is our monthly meeting. So if we don't have any other business, I will go ahead and, do you have something?
It came upon a full app.
I found a Linux news app that collects like a dozen different news feeds.
Great. So he found a Linux in the News app. So next month, look for me reading off a tablet. Okay? So without further ado, I think we're going to go ahead and announce the topic of the presentation today, which is now up here. This is for all of you out there who are using wonderful languages like Python or Java or all those fancy up and up languages, and then you realize one day that this just doesn't work. It doesn't do what you want. You're sitting there cruising through the networking APIs, and you say, this just isn't good enough. I need speed, I need power, I need reliability. And you sit there and think to yourself, well, what can I do? And then you remember, wait a minute, all of this stuff is written in something more powerful than what they've given me. And you go digging through the APIs in the stack, and pretty soon you are programming in the most wonderful language there is, C. So, without further ado, I would like to announce tonight's speaker. Dustin Laurence is a software engineer who will teach us about the survival using C for all of us that have been stuck in high-level programming language far too long.
Oh, there was a microphone, you want to use?
Right there.
after that, I guess I have to say I'm excited about C. I actually, when you brought up some of the security things, I actually gave a talk on security, but I realized once that nobody knows what I mean by security. They're thinking about, like, you know, staying up late at night to patch the company server so you stay in business, which is, you know, okay, but not as important as what I mean, which is basically to make those guys never have to do it. So usually for me, what I think of as security is sort of how to write things so that the security team never is actually patching it. That is, however, not this talk. This is slightly different. I also should introduce my tech crew here, who, this is Eric, who wanted to come along and run my slides, so we're going to see how that works. So, without further ado, the title is Survival at Sea, and what we're going to look at is something which is kind of like taking the red pill. When I learned C, that was a perfectly normal thing to do. I like to say it was my first language, but that's lying, but I lie that way. It was just the first good language I used, and it was perfectly normal for, you know, freshmen to learn C. Nowadays, I guess the majority of good programmers who learned anytime after, what, the 1980s, don't use C much. Except, of course, there are times when you eventually will learn C, and that's what we're going to talk about. Next. Okay, so here's a few quotes that I like that are in some way relevant to C. First of all, it really is like running a chainsaw with the guards removed. And I have a long talk that I've given about that. We're going to not talk about the really scary parts tonight. But the second quote is really important. C is a very problematic language for a lot of things, but we use it very heavily. And you know, sometimes even for good reasons, sometimes because, you know, we refuse to learn anything else. The other thing here that I really like from Churchill about how exhilarating it is to be, you know, to be shot at. That sometimes that's how programming in C is. So anyway, go on, Eric, next. Okay, so what are we talking about here? We're talking about sort of the core audience here. I'm going to assume, is that you are a good programmer. You know how to program, but you're programming in the standard languages we use today, which is no longer C and C++, by and large. I assume that your Google flu is strong, okay? You probably own a lot fewer manuals than I do because you check online. So I don't need to talk about that. We're going to instead talk about how to build some expertise in using it correctly, which is not nearly so obvious because C doesn't really help you that much. One other point I want to make, just because I think you should know it, I'm really just covering C mostly. We'll talk about C++ a little bit. I'm covering it as a language in its own right. And most people that I meet that are younger than I am that say they know C actually know some C++, and they say they know C because they were told once that C is a subset of C++. They don't know which subset, but they kind of know it. And that's not how you get the best out of it. The other reason is that C++ is just way too big to cover this way. So, okay, so what are we going to do? I picked what I thought would maybe be the three most useful topics for this. The first one is that you already have design skills, okay? But therefore a much more modern type of language. C was never meant to be object-oriented. But we can leverage your skills anyway. We're going to talk about managing, doing manual memory management, because when I've talked to people who've never used C, that seems to be the thing that terrifies them the most. And then we're going to talk about what I think is really the right way to handle exceptions in C, and that one is partly defensive. I might someday have to read your code. And I hope to read things that are vaguely like what I'm going to describe rather than ad hoc exception handling because you no longer have language features to help you. Go ahead. All right, so this is our first topic, okay? We're going to leverage your existing skills. We're going to write somewhat object-oriented C. Okay? So, I assume that you're trained in that. Most people are. Okay, so we're going to bend C to our will, essentially. I do want to say this is not condescending, and I'm not talking about this is my mature C style. This is the way I write C out preference because it's better than the procedural way I learned. Go ahead, Eric. Okay, now, so here's my dogmatic claim. Okay, what I call object-oriented C is actually better than what C was designed to do, both, especially for people trained to use object-oriented languages. I think that's inarguable. Actually, I think it's better for everyone else too, and even though there are people who disagree, I mean, they're wrong if they disagree with me, but really what we're doing is we're just going to ignore a bunch of sort of legacy mental cruft, and we're going to do it right from the beginning. So what do we have? Well, we have three aspects. I mean, people don't even really, there's no single definition of object-oriented programming, but we have kind of three things we talk about, okay? First one is encapsulation. I'm going to make the dogmatic claim that experience says that's entirely a good idea, that's never the wrong thing, okay? Polymorphism, which I'm going to claim is usually good in practice, although, especially for certain kinds of programming, it does have some issues with slightly magical effects of not being able to tell exactly what implementation is actually going to be called. And then we have inheritance, which I actually claim has turned out to be quite problematic in practice. So, since we're going to have to retrofit this from scratch, what is worthwhile in C, and what can we get at a price we can afford, okay? So basically, we're going to look at a few sort of key high-value techniques and not go any further than necessary because it gets costly. And you can probably already guess, given what I've said, that we're going to really focus on just sort of tightening up our encapsulation as the sort of the highest payoff features. Go ahead. So what do I mean by encapsulation? Well, nothing complex. I mean, you're hiding your implementations behind that really should say opaque interfaces. And I claim this is the most useful thing. I claim we don't actually know anything about programming. That explains a lot about the world of programming. If you realize we actually don't know what we're doing, we kind of have to make it up because we don't have a mature field yet. But this is the one idea which essentially has stood every test, and we use it everywhere we can. And for C purposes, what that means is that we're going to create modules. We're going to use modules to represent classes and structs to represent objects. And the nice thing about these things is they're essentially free. You can use them anywhere you can use C. You don't have to worry about whether you have enough room on your little 8-bit embedded system to do this. And for those of you that know C++, honestly, this is the style of programming that C++ began to automate. So in fact, this is actually a very old way to do it. All right. So we actually have direct support for modules in C. But if you come to C from other languages, you might imagine that if you want modules, that somewhere there must be a keyword that says module. And that would make sense if you were using a language like Python, which wants to hold your hand and make it obvious. That's not good enough in C because we don't want the unwashed masses to know what we're doing. So basically there's no module keyword, but we have the semantics, okay? What you end up doing is each module you want to create is a single compilation unit, basically a .c file. And all we do is we have this keyword that makes no sense, but we call anything that was a private part of the implementation, we declare them static, which really just restricts their scope to that file. We declare the public functions normally, and then we just export the public interface to the .h file. The private interface is at the top of the .c file. That's a little nicety if you're not quite up to speed on C. You don't have to do that in the sense that the C compiler will accept you kind of just declaring them. But you shouldn't do that for first reason is you should have your compiler flags tweaked up to the point where it will demand prototypes anyway. If you don't know how to do that, that I didn't have room to actually talk about that. But the other reason, the even better reason you should do that is, and then that someday somebody will refactor it and then start moving around functions and they won't be able to call each other. So you just put all the prototypes at the top of the .c file, and now it behaves the way it probably would anyway in a more modern language. All right. So again, there's no downside to doing this, no runtime cost. It's use this pervasively. Okay. People who don't do this, well, they'll be first against the wall when the revolution comes. If I ever get it. Okay, now the nice thing is if you have modules and structs, it basically means you can actually create very simple object model with the tools you already have. And the reason is that a module is essentially what we really mean. I mean, it has the semantics of a class. All we're really going to do is we're going to move private module data into the struct. In fact, you can view that as just saying that objects are just modules that I can create and parameterize at will by the data that I fill in. And that's all we're going to do. We just move our private data into the struct. We declare the struct in the .h file, okay? It's a good idea, I think, to have a distinctive naming convention for that. C, just, again, so if you a lot of languages, you sort of grow up naturally using a lot of camel case. C, idiomatic C, usually people will use lowercase and underscores. So the nice thing about that is if I put things which represent a class or an object in camel case, then it turns out that it won't collide with anything because nobody else uses it for anything, and it stands right out. And then it's obvious throughout the code base exactly what has object statements. And then all you do is you just implement your functions. The first parameter, you pass it in one of these objects. You name it self because, well, that's what we all do. And this was a stupid idea, so we call it self. And then basically your class attributes are just the way you did it in modules. And your constructors just are things that return an instance struct. Now this is not hard, but if you've not really used C much, it's not obvious that you should do this. And so part of the reason I'm talking about this is that I want to sort of bring you up to speed. This really is the right way to do it. Again, this was done pervasively enough that in reality, the design goals of C++ back when it was called C with objects was precisely to just support this pattern. Okay, now there's here's a few things you got to know. The first thing is a real object or in language, of course, will give you a namespace for every class. You won't get that because C wasn't designed to do this. So what you're going to have to do is you're going to have to do namespaces the way you always do it in C. You just prefix things. Everything's going to get dumped in the global namespace. The way I do it is I'll prefix every method, as I illustrate there, with the class name. Okay. And if you expect your code to be reused anywhere else, or you're using a lot of other libraries, to be honest with you, you probably should namespace the whole project. So since DLL are my initials, that would be an example of doing that, but make it short because these are not really namespaces and you're going to be typing that an awful lot, okay? If you're worried about the fact that somebody else could use that, there are hackish ways to fix that, but I don't want to talk about it. You can ask me later. Okay, so one of the things people say is this is really ugly, okay? And my answer to that is, well, first of all, you know, your aesthetic sense isn't tuned for C yet. It's tuned for, you know, whatever your favorite language is. So don't worry about it. Worry about whether it works and is bulletproof. Honestly, I think beauty in C is really well-written C is more like the beauty of an A10 popping over the horizon to save you. It's not elegant, but it's very effective. And that's kind of what I think of as beautiful in C. The other thing is, if you notice that languages that have very nice full namespace semantics, always after a few years, the best practices document starts to tell you, don't use the using statement very much. Fully qualify your names because stuff collides, and this way people actually know where they're coming from. So we can actually make a virtue of necessity and point out that, you know, we're going to do that because the compiler will enforce it, basically by not meaning to do namespaces at all. Okay, there. Okay, so at this point, this is an awfully simple object method. I'm going to digress for a minute. This is something I don't want to talk about and I try never to do. You can actually go a lot further, okay? So you can actually there are interesting ways to hack in things like a dispatch method, okay? There are interesting ways that you can either, in the old days I would have actually done some kind of single inheritance model like C++ does. These days, honestly, I think I would actually just build an interface object model. The problem with doing all of this is that at some point you are sort of committing desecration, and there will be a price, and so you don't do this. what I want to talk about instead, this is beyond anything we can talk about now. So instead, let's talk about how to get the most out of the very simple model, because the simple model you can use anywhere. Everything else starts to have costs that you might not do in every case. Okay, so how do you do this? Well, okay, so it turns out that most of the things that you get in a more dynamic language, you actually don't use all the time. Okay, in fact, usually people engineer not to do that, unless you're the sort of person that likes to monkey patch everything you write in Ruby, you probably have some mental rules about not using the dynamism very much. Okay? And it turns out that you can do much of what you want. Much of your design skills will still work. You just have to know how to interpret them a little differently. For example, much of what you would get from polymorphism is simply the ability to call things. In C++, its polymorphism is generally subtype polymorphism. The point is that much of what you got from it, you can just give your classes. You can just give them a method which converts them in the correct way, which is, people will say it's ugly. Well, it is. It's very explicit. Okay, and one thing that I'll probably touch on later, if you'll notice, one of the design goals of Go was to not have nearly as much magic stuff happening. Well, in C there is no magic unless you make it happen. It's explicit. Okay, the other thing is, the best practices of languages like C++ that were initially designed to build these beautiful object hierarchies, and of course the best practice now is don't use inheritance unless you really, really need exactly that relationship. You should basically compose objects, okay? Well, the point is that's all we're going to do here. Notice how in some sense we're getting a little bit of benefit by not having followed the trend because we're not going to get a lot of things that turn out to be a double-edged sword. Okay? The other thing, and this is the hardest part, I think, of this and the most beneficial, and that is that one thing I discovered doing this is that when I write in a language that makes it easy to create classes and inherit things from other classes, I make too many classes, okay, because it's easy. Okay, and this is what gets called ravioli code, okay, because everything is broken up into little tiny units, and these units use other units, and actually finding out where everything is kind of a pain because you have 6 windows up to figure out what the real implementation of class is. I found that what I did was I created fewer ones, and I had to think harder about what are the really important abstractions in this project, and then lo and behold, it got easier to read, it got easier to write. And the fact is, I should have been doing that all the time. So in some sense, I was abusing the facilities in a language like C++ or Python. What I was actually finding was by having to work harder at it, I made better choices. Okay? So it's one of the lessons that I think you take back to your favorite, your high-level language is to rethink just how much, if you're like me, how much you try to reify every possible abstraction into code rather than use. I have one thing where I found out that if I made a really good stream class, I could use that for nearly everything. If I had a stream class and I had a little array class, I could do almost everything with that, and by God, that was much easier to read than what I had originally wanted. There's one other thing that will be unfamiliar to you because most of the modern languages always pass objects by reference. It's entirely possible to pass them by value in C, which is why you can do it in C++. You should be very careful doing that because that can do bad things. However, for little tiny utility classes that are they're very simple and lightweight, that turns out to be very, very nice. Okay? And especially in C because you can't do anything like overload the copy constructor. And so if you want temporaries, they're going to be just structs. So that is actually a very handy use as long as you're careful how you use it. Okay. Again, although this sounds like a very stripped down, half-baked object model, it's actually very productive, especially if you compare it to trying to write purely procedural code. I try to stop here in C unless my back is against the wall because beyond this, it starts to become too fancy. And now it becomes, you have to make trade-offs, not just with performance, but with readability. Okay, so basically what are we getting here, okay? Actually, I think I said much of what's on here. Okay, less ravioli code. Things get very explicit. There's no question about what got called because there's no magic dispatch. And I guess the final thing here is that the less is more that C kind of forces you into, I actually found to be a very good design discipline, at least for me. Apparently I'm too extravagant by nature. Go ahead, Eric. Okay, so what's the next one? All right, manual memory management. I call this doing the impossible because of a strange phenomenon that I remember from the days when Sun went out to, or their marketers went out to save the world from the perils of using anything like C or C++. And so this slide is the great marketing schemes in history. The guy with the name, no kidding, I am not joking, his name was King Camp Gillette. He had a product to sell. And so what he did was that he started referring to the straight razor as a cutthroat razor. Brilliant marketing. And his own razor is a safety razor. And they convinced the public that straight razors are just too hard for ordinary men to use safely. Okay? And that created an industry. Now, I don't know what, 90, 100 years later, Sun built a marketing machine. As Ellie said, Sun punched above their weight in public visibility. And they convinced managers that C and C++ are just too hard for ordinary programmers. Now, they convinced some programmers too, but that was not relevant because they understood how COBOL had become such a juggernaut in the business world. So they sold to managers. And what they sold was really that you can hire cheaper programmers and sort of trade them, hire and fire them as fungible units. And I mean, and to be fair, it really sucks to manage people who are smarter than you are, do things you can't understand, and you can't fire them because you can't replace them. So, and it sounds like I'm being sarcastic, but that really is a problem for a manager. And so if you promise managers that, it will sell every time just as much as when the Air Force promises Congress that they will not have to commit ground troops again if only they give more money to the Air Force. It works, okay? And the odd thing is that it works so well that people forget things, okay? They forget that millions of people shave with straight razors and they didn't actually die. Okay, my brother actually shaves with a straight razor. That's almost all he uses. So it turns out it can still be done, and strangely, it turns out you can still do memory management in C. Okay? And so with that, let's just try, I just want to make some points here. So it's absolutely true that manual memory management is harder than having it automated by your runtime system, but it just isn't even as hard as problems we tackle all the time, okay? It's not harder than doing parallel programming. It's not harder than distributed data in general. And if you're willing to tackle those, then frankly, you know, it's hard for me to see why manual memory management is a problem. What you do need is a couple of new skills and a mental picture, and that's what I'm here for. You don't need superhuman talent, but I'll tell you what's really fun. When particularly credulous and fairly young programmers treat you like you're some sort of wizard because you do something that we used to teach the freshmen. And that's kind of fun. Okay, so now I have to tell you there's no Santa Claus, and that means that I have to tell you that memory management is really a design issue in disguise. And if you don't recognize that, your conversations will make no sense. And I know this, I had many of them. I know this because I spent a long time figuring out why my conversations made no sense, okay? So let's just talk about why that's true. So let's imagine we have a perfect garbage collector, okay? So that means it will collect any memory which is no longer live, which is dead. It will not be accessed again. It will never collect memory which is live, okay, for any program. That's what it means to be a perfect collector. Okay, now, but for any program, I can take the entry point and insert an extra allocation, okay? I can do this in the binary. This has nothing to do with the language, okay? And I can find all the exit points, and I can dereference that piece of memory at those points. It's not dereferenced anywhere else because it didn't exist. I can do this in polynomial time, so it doesn't change the difficulty of anything. Okay, now here's an interesting thing. So my perfect collector will collect that memory precisely when the program never halts, because that memory is dead. It will never be accessed again. It will never collect it when that program will halt, which means that my garbage collector is a halting program solver. Okay, a halting problem solver, and the only problem with that is we already know that that's an undecidable problem. The point is perfect collectors don't exist, all right? So in any language, we actually have to restrict our designs to a special subset of programs for which the collection system, whether it's our brains or, you know, a very fancy semi-space collector, for things they can handle, and that's what I mean by there's no Santa Claus, because the converse of the cutthroat razor was the safety razor, and the converse of terrifying, impossible manual memory management was that the collector would just make all your problems go away and everything would work, okay? Those of you that have tracked down memory leaks because people didn't know their pointers have some bitter memories of why that was a bad idea. Go ahead, Eric. Okay, so this is kind of a conceptual diagram. Don't try to think too hard about how to make it precise because I'm not proving anything. I'm drawing pictures in your brain. Okay, so the space of general programs is something like the space of all binary strings as executed by the, in machine code. The point is that we've already proven that they're impossible to collect. Okay, which sounds kind of bad because that's most of the programs. On the other hand, they're impossible to understand in any way whatsoever in general. So that's not the trouble. We never write those programs. Now, the bigger area there is what I'm calling collectible programs. They can be collected by scanning, and what that means is that is a very special set of programs for which reachability is the same as liveness. Because while we can't perfectly collect dead memory and leave live memory alone, we can do a perfect job. We can precisely collect non-reachable memory, okay? And that's what we do. The next smaller one is what I'm calling countable programs, meaning you can count them with counting collectors, which is basically the same as before, except the memory the memory when it's reclaimed, it has to be cycle-free, okay? Which is actually a significant limitation when you go to try to figure out why things get leaked sometimes. And then the smallest one there, for lack of a better term, I'm calling manageable programs, which means you can do it by yourself, and that's where this thing comes in that I'm about to unpack. The reason that it laughs out there is that you can do crazy things you should never do, that your collector has no notion about, that you can deal with manually, like, XOR all your XOR pointers with -1 and keep them around for a while, and then XOR them again, write them out to a file, play them as audio, and then ask the user to play them back. And the point is that you can always make them inaccessible. There are rules that we have to follow, even with an automatic run. Go ahead, Eric. Okay? So in language with precise collection, we just designed so that the programmer can deal with it, which for precise collection, okay, with scanning collection, it means that instead of having to deal with the liveness of memory, we only have to deal with the liveness of individual references, which is much, much, much easier. And that's why it works so well in practice, okay? If you have reference counting, you have to do that, and the programmer has to be able to determine, again, statically from the source code, if we want to actually maintain this thing, when cycles exist and that need to be broken. If it's manual memory management, then the programmer is going to have to be able to determine statically from the source code the liveness of objects themselves, which means he has to do the whole shebang, and that's why it's hard. So how do we do that? Well, I'm going to make a sweeping irresponsible claim, and I'm going to say the most general, useful design principle for this is what I'm going to call sole ownership. Just out of curiosity, who has ever heard anybody talk about sole ownership for memory management? Anybody? Okay, so all right. I'm glad to hear that because I don't tend to hear people who've ever heard of it. Go ahead, Eric. Okay, so what do I mean by that? Okay, at every point in the life cycle of a chunk of memory, there is precisely one reference that has the sole responsibility for controlling access to it until its final fate, where it either frees it or passes the responsibility to a new owner. Okay, now just to contrast it, if you have collection, whether it's scanning or counting, ownership is clearly shared. All references, or at least all strong references, have a share in the ownership, and that's fine because the collector will discover what owners actually still own a share. But we're concerned with C, and our minds can count to one. So we are going to have one share of actual ownership out at any one time. Okay? So when I say ownership from now on, it pretty much just means that. Go ahead. Okay. So now what can owners do? Owners can, first of all, well, besides accessing the memory, they can allow another pointer to borrow the reference. Okay? That doesn't transfer ownership. Okay? They can transfer ownership to another owner, at which point they relinquish it themselves because there's only one owner. Okay? But owners must free any memory they own before they either go out of scope or are freed themselves. And they can only loan to borrowers whose leases will expire before the loaning owner needs to transfer or free. Okay? Go ahead, Eric. All right, now borrowers, what can they do? Well, they can freely access memory during their tenure. I should just point out, I'm ignoring anything like shared memory here and threads because that causes enormous confusion, doesn't actually help anything. So you can just imagine it's single-threaded for now. Okay. The other thing they can do is they can grant subleases. Okay, they can loan the thing that, I have your mower, and now I've loaned it to my buddy. Eventually you'll get it back, but maybe after it's mowed the entire street, and you'll thank me for that later. But borrowers must not free memory, ever. They never do this. They never pass the memory to an owning pointer because that really amounts to saying they can never convert a borrowed pointer to an owner. They can never convert a lease to ownership, and they themselves have to be able to guarantee that any subleases will expire before their own does. Okay? Go ahead, Eric. Okay, so what are we buying from this discipline? Okay? Well, what we've actually done, one of the crucial things we've done, is we've eliminated kind of non-local, sort of the global problem. And the reason that memory management is so hard is it's basically a global problem. We have to worry about a pointer anywhere that might reference that. Okay? The nice thing about these rules is all of your decisions now are local. Okay? And not only that, but the correct point to free memory is always evident lexically. It's not a dynamic quantity because it's the point at which an owner is freed or goes out of scope. Okay? Functions tend to be simple to write because they're only responsible. They only own things that they've allocated themselves. Mostly, that's usually how we write them. Okay. The other thing is it's very easy to religiously null all your pointers after. So how many of you that do program in C or C++, how many of you religiously, without exception, null every pointer after you do a free or a delete? There's 1, 2, boy, we're in a small minority here, but we're going to go back to back and protect ourselves from the unwashed masses. That is the only right thing to do, folks. And the point is that it's also very easy to do that because, again, you always know when things are no longer going to be used, okay? And there are several reasons you want to do that. A simple one is that if there's anything worse than having a program crashing, it's having it churn along in some state you don't understand, and then have the boss ask you to find out why every 2.5 months the server goes down with no obvious symptoms. Okay? That's not a fun place to be. Go ahead, Eric. All right, so now here's another, because my business, I regard my real talent as bold, irresponsible, dogmatic assertions, and everything else just gives me things to be dogmatic about. I will just flatly state a design whose management strategy, if you can't express it in the language I just gave you, okay, it's a bad design. Now, you don't have to express it that way, but you should. Go ahead, Eric. Okay, now, why don't you see all C programmers doing this? Okay, well, they're mindless, but oh, I didn't say that, did I? Did I write that on the thing? I only thought it, right? Actually, you'll find if they're good, their designs actually will usually be describable this way pretty well. The problem is just that they don't use this language. They probably learned the hard way not to do this. And the goal of this talk is to not make you spend 10 years learning the hard way, but to try to set you on a reasonable path immediately, because presumably in the scenario that I kind of wrote this for, you probably are doing this because you have a job that should get done in less than 10 years. It's much easier if you know what it is explicitly. It makes me better, because now I really know what I'm doing, and I might have a gut feeling for things I shouldn't do, but I'll sooner or later be wrong if I don't really know what I'm doing. And at this point, as soon as you chew on this a little bit, you kind of get some practice using it, you're already now better, or you have the tools to be better than at least half the C programmers out there. That's not bad for like 15 minutes, right? Go ahead, Eric. Okay, so actually, let's just talk. It's nice to relate this stuff to C++ because there is a relationship, and I've been trying to tell you that you can take lessons from C back home with you to your other, your other more powerful language. And these ownership concepts, this language actually comes from C++. I don't know that it originated there, but that's where the only place that I've really encountered it being really understood. Okay? And that community may have invented this, and it just turns out to be what we should all be using. The nice thing in C++ is you can automate part of it. Okay? You can have the compiler enforce it by teaching it about ownership, because that's really what AutoPointer does, folks. And what's nice is that you can factor out the details of the freeing with RAII, and then you just own your RAII objects with auto pointers, and you've nicely factored out something that knows all about ownership but nothing about how to free your objects, and objects that know how to free themselves. Okay, now when we do this in C++, when we borrow, we're probably going to use ordinary C pointers. Unfortunately, we can't automate the borrowing rules. Okay, C++ will let you get away with a lot of crazy things, and you can get away with a lot of murder, but not that. Okay. And just as a kind of irrelevant aside, but it is vaguely in the general topic, starting with C11, C++ 11, if you're lucky enough to be able to use a recent version, you actually do have counting collection available to you. I do want to give you one little warning. If you are used to full scanning collection, it's actually surprisingly easy to do bad things by assuming that shared pointer means you don't have to do manual memory management. It's surprisingly hard to find cycles and break them. And I remember having a conversation about this where I said, all right, look, where are the owners here? And two things happened. Number one, I think that they tried to treat shared pointers as though they did full scanning collection and they were losing cycles. The other thing was the ownership language always helps. What they really had was a doubly linked list, and there was no real reason to have every object in the list own each other because they weren't doing anything that needed that. And if you could avoid creating them in the first place. They did it, I think, because they wanted them to be like pointers in Java or something. They're not, okay? And so I'm just warning you, you do have to understand them for what they are. Go ahead, Eric. Now, so here's a little more dogmatism. This is the same thing but said in C++ language. Okay, if your design doesn't allow your memory management strategy to be implemented cleanly in terms of auto pointer, it's a bad design, okay? Unless you're using something, other smart pointer. But the other thing is, if you're not actually using auto pointer to implement it, then your implementation is basically flawed. This is the right way. Even auto pointer before C11 kind of automates everything you want except for putting things in containers. And shared or unique pointer fixes that in 11. Go ahead, Eric. Okay, now, there's one other thing that's rather interesting. There's a language called Rust, and somebody mentioned Mozilla. This is actually out of Mozilla. The nice thing about Rust is that they took this vocabulary and this logic that I just outlined for you, and they built it into the language as the entire memory management scheme. What's amazing about that is essentially that memory leaks are a type error. So programs which compile in Rust do not leak memory. If that doesn't excite you, you have not spent enough all-night sessions looking for memory leaks, And yet, you pay for nothing because essentially it's free. You're not paying for the cost of a collector, which is considerable if you're using you're using these languages presumably for a reason, and that's probably why. The other thing that actually proves is that these rules are sound, okay? You can automate, they're simple enough to automate, and you can build on them as your sole model, and they work. Go ahead. All right, so final thing about the sole ownership, I want to make one more point. You can take this back to your fancier, more higher level collected languages, because that wonderful garbage collector only collects local memory, okay? And there are lots of resources that are not local memory, and sooner or later you can find yourself in a position where you start juggling a lot of them, okay? And ownership and reference counting really are the ones that work for any resource whatsoever. They don't really depend on the special properties of memory. Things like I can walk the stack in the heap I can identify all of my roots, walk the stack in the heap, and find everything that's reachable, okay? That's not true for, objects I hold over the network, database connections, files, memory that's, in the space of another process. I can't do this, okay? And the nice thing about this language is it works for everything. And so you're not likely to ever need it for memory in a collected language. But in difficult cases with other resources, I insist it is still the best way to handle these things, okay? Go ahead, Eric. One more. There we go. Final topic, and this is manual exception handling. And the reason that I wanted this in here is I might have to read your code someday. Okay, go ahead, Eric. Okay, so what do I mean by exceptions? Well, if you've only used languages that have a language construct, people tend to use exception to mean some language construct, probably with the name exception. I don't mean that because we have no constructs in C. I mean the things that those constructs are designed to help you handle, which is exceptional conditions that are not part of the normal flow. And I'm sorry to tell you, because I'm sure you will be heartbroken, there's really only one way that actually works in C to handle that, and that is returning error codes. Yep. Everybody goes, boo. There are a couple of ways to try to get out of this. Just don't, okay? Just take my word, because it's a sad, you will be sad, okay? And in particular, when someday you're digging through the C library and you discover something called long jump, okay? And you get really excited because that's how you can jump back up the stack. Put it down, lay down in a nice dark room, put a cool cloth on your head, the fever will go down, and you will be able to prevent yourself from doing something that will lead you to a world of hurt. I can tell you why, but that's not during the talk because I don't have time. Okay, so go ahead, Eric. So, first thing, maybe the most important thing. Whatever you do, don't do error codes like libc, okay? This is where I've already insulted everybody who likes nice modern languages. Now I'm going to have no friends because I'm insulting the old-time C hackers. The error no interface is basically it's weird, inconsistent, and error-prone. Actually, to be honest with you, most of the interfaces in libc are weird, inconsistent, and error-prone. Sometimes you use these magic in-band values. Sometimes you use out-of-band values, but on the same variable that would report a result. Error no used to be a global variable. Now it's something weirder and more magical because it looks like one, but it's thread local. Some standards say certain functions set error no and other ones don't. Sometimes error no is only meaningful to check if you've already indicated an error by other means. Other functions, error no is the only way to determine if there was an error. Okay, it's bad. Go ahead, Eric. Okay. So this is just a digression, but if you're going to work in C, you're going to have to face libc. I want to give you a few survival rules. Okay. The simple way to make it so that your usage of error no is actually auditable without the person reading the man page for every call you make is you always zero error no before every call that can set it, because that is guaranteed to be okay. And then if it's set, if the function says you should read it, or if it said, if you have to read the man page in a row, because it's weird and inconsistent, remember? But you then have to read it immediately before you make any other call. If you change it, yes, life sucks. I have a tendency to immediately copy it into a variable called ERR underbar NO if there's any doubt, so that I've already saved the value that I wanted, just in case someone later comes in and refactors the code and sticks another call in there. There are also, in recent Cs, there are some things like memset S rather than memset. Which is nice because the C compiler knows about memset and will optimize it away in the cases where it was preventing your private cryptographic keys from possibly showing up again in another piece of malloc memory. So it's not allowed to optimize the S variance away, and they probably actually bounds check, check the map page. Otherwise, the end variants usually are somewhat better, but I forget which one it is, like stir in cat, will fail to terminate your string in one case. It's crazy. Okay, it'll probably insult your mother, probably send in SA goons to your door, and that's just a day in the life with libc. So feel free to wrap it inside safer interfaces and try to get your company to do this consistently, because it's just hygiene for everybody, folks. So I'm sorry, but libc, go ahead, Eric. Like I say, this is the bottom line. Just never imitate libc. Never imitate the exception. Never imitate anything. We thought it was a good idea back in 1970. We got help, but there are still 10 billion mission-critical lines of code that depend on its exact quirky, weird, and inconsistent interface. So it will never go away. But be aware. Okay. So how do you do it right? Okay. First of all, you never return results and report errors with the same variable. Okay, and that kind of simplifies a lot of things. You don't split the detection reporting. That's a hack in libc. Oftentimes it will return a yes, no, there was an error in a variable that otherwise returned a result, and then you have to check error, as opposed to one of the other 5 ways it does it. The other thing, and this is really the major message I'm building up to, that's hard to explain. Work very hard to write your functions so they either succeed or they leave the program state unchanged. How many of you have been told to do that? Okay, a few people. I'm happy about that. How many of you have no idea what I'm talking about? Okay, be honest. At the very minimum, don't leak memory. But really, what you want to do is make it so that the program stays unchanged, which in a certain community calls strong exception safety. Go ahead. Why do we do this? Okay, what it really means is we're going to start thinking transactionally about our functions. Okay, you'll see why in a minute, so just bear with me. One of the reasons is that if you don't do this, then even if you document what might have been changed when the error comes back, that function is going to be called by other functions which will do this. And you would have to know all of the changes made by all of the functions that might get caught. And it's a mess. This is the only one where you can compose sort of sane functions and get more sane functions, okay? The only problem with this, Eric, you go back a second. The only problem is most of us were not taught this discipline, and it sucks, okay? But nonetheless, I'm sorry to tell you it's the right thing. Go ahead, Eric. Okay, so how do you do that? Well, basically the best way that I have ever seen is what I'm about to show you, and that's 2 little patterns for how you write things. One of them I call the C exception reporting pattern. It has 2 variants, and there are people who will argue passionately for both. One of them is, and this only applies to functions that have an error return. Functions that have no error case, fine, do what you want. But for functions that have to report errors, they always report to the return value, and nothing else is ever returned that way, okay? Which sounds odd because you're used to using the return values so you can make nice little expressions. But remember, we're going to be beautiful like an A10 warthog and not like a conch or something, okay? The other way to do it, the other variant is that the last argument to every function is a little reference parameter that will take the error code. And I don't even want to get into the arguments people have over this. They're perfectly fine. I do recommend you be consistent across an entire project. Go ahead. Now, that is like the bumps on the Lego that fit into the sockets of the C exception handling pattern. And this is a little bit more involved. Every function has the same outline. This is why I want you to do this if I ever have to write your code, because this is otherwise I have to read your ad hoc error handling. Okay, what you do is, by the way, if you've ever seen kernel code, the kernel does this extensively. You acquire resources, whether it's memory or whatever, file handles, you acquire resources at the beginning of the function. You do this in order, okay? You do your work in the middle, but you never change the output variables, okay? At the point at which no more errors are possible, because you only have operations like copying variables, at that point you can assign them to the output variables, and then you release them in reverse order. Now, why do you do this? Because of the rest of the pattern. In the acquisition section, if you make an error acquiring a resource, you go to, you go to the label you have put just before the code that releases everything that's been allocated up till now, right? Now, do you have to release, the error was in acquiring resource in, do you have to release resource in? No. The answer is no. Why is it no? Because you're writing strongly exception-safe code, which means you've guaranteed that you don't have a partially constructed object. No state has changed, right? You can't release a partially constructed object because whatever you're using to release it assumes the whole object is there, but you can't not release it because it's got something. You never want to see a partially constructed object. That's part of what you buy with the discipline that I just told you. So now you just release everything that was allocated and you go. If you have an error while you're doing your work, then what you do is you jump, now you know everything's been allocated, so you jump over the commit section because you're not going to change state, and then you just release all your resources again. Okay, and that's the pattern. Go ahead, Eric. Okay, oh, yeah.
You actually advocate that go to?
I absolutely do, and but I know that reaction is there, and it's visceral. Okay, and I have to tell you, it took me quite some time of talking myself out of the religious catechism, which I had received as a freshman, and you may still have that catechism because I was much older than a freshman. So let me give you the 2-minute version of this. The rule against go-tos was a terrible misapplication of a perfectly good idea. Okay, what it really was about was something that works. What it was about was the approximate equivalent of me saying that you can play arbitrarily good chess. You can play as good a chess as you can afford simply by doing enough look ahead in the decision tree. So therefore, when you learn chess, you should look ahead as far as you can. Now, what's the error? It works. The problem is it doesn't work for human beings, okay? Because human beings don't do that. What we do is we recognize patterns extremely well, so computers will rely very heavily on look ahead, and whereas humans rely almost entirely on position evaluation. Both of them work perfectly if they're perfect. What I'm saying here is that human beings can recognize a fairly involved pattern provided that it is stereotypical and always the same. So even though this is an odd control structure built with GoTo, you're going to do it the same way every time. And if you don't, your coworkers have my blessing to hunt you down and hang you in your cubicle, okay? Because really, the no GoTo rule is not a rule for programmers, it's a rule for language designers. Every time you find that programmers have a control structure, which they need and have started to sort of build into an idiom, you reify it into a statement and give it to them so that you no longer have to squint and make sure it's really that one, okay? So in Fortran, certainly in Fortran 3 and maybe in Fortran 4, a while loop is basically the following. If not the condition, go to break, the label after the loop, otherwise do my body and then go to up to the test again. Now, is that an evil way to write a while loop? No. It's the correct way in a language which did not where the designer has not yet noticed that we all need that pattern, and so we reify it into something called while, so there's no possible mistake. Okay, when C was written, this pattern was not widely enough used for anybody to decide that no self-respecting language would live without it. Now, they have a case statement. You know what a case statement is? It's a bunch of go-tos hidden behind a statement which reifies it into something where there's no question about what it is. So in a more recent language, what your exception handling is it's a way to take a pattern which you need and make it kind of bulletproof, but we don't have it in C. So either we give up on a pattern we need because some pinhead said that, you should do it wrong, or we do it correct circa 1970 because the language was designed then. So I realize I'm kind of being tendentious, but the point is that, you gotta think about this for a while, because I understand very well that at least half of you have this queasy feeling in your stomach, because I remember this too. When you flunk, when you get graded off because, you used to go to, if you remember. But this is really right, okay? And this is really the way to do it in C. It's just kind of hard because it is not allowed by your religious catechism and mine. Okay, I'm just apostate on this point. I believe that the Donald Knuth wrote an article called "The Tame Go-To" or something like that. And if Donald Knuth, Donald Knuth is big enough to argue with Edgar Dijkstra. Okay, so what? Let me go on though.
Actually, the title was "Go-To Considered Harmful." Well, considered harmful.
Well, I don't. Was that?
I think that was
I thought that was a different paper. There was a whole flurry of papers in the proceedings of the ACSM. Okay, so one of the rejoinders to Dijkstra's article was by Knuth. I thought that one you're mentioning was a different one, but I could be wrong. Either way, it was a big deal. Okay,
Yeah.
and it might be worth looking at. Anyway, the point is that there are 3 places in C you should use go-to. Okay? I only can think of 3, there might be another one. 2 of them don't show up very often. One of them is when you're implementing a finite state machine. It's one of the really good ways to actually implement state transitions. Okay? It's better than the alternatives, except there's another one, I forget what it is. I think it's using a jump table. The other one is if you have a deeply nested loop and you need to basically continue or break out of it, but you need to break out of the outer one, because C makes the mistake of not giving you a break or a continue to a label or a number of levels. So again, they just didn't give you the tool you needed. So you're stuck with a language which doesn't have all of these things to sort of hide the go-tos. And you'd rather hide them. But we don't have them, and it's okay if otherwise if the loop is clearer that way than some other way, then I would say that's fine. Those don't come up that much. This, I claim, should happen constantly. Okay, so let me go on because now I'm kind of exceeding my time here. What is anything here that I did not say? I think I've actually said everything here, except notice at the bottom, consistency is at least half of readability. And part of the answer to this whole, we can't use go-to thing is that general go-to structures are not consistent. They're ad hoc, and yes, we can't read them. Okay? Stereotype patterns, which are an idiom in the community, are not the problem. It's just that if we did it over again, we'd put in a statement for it. We just don't have it. Okay, so a few things because I'm going to basically wrap this up. I want to connect this with C++. The language I'm using, I said that it's a particular community that uses the phrase strong exception safety. It's the C++ community. That seems to be where this was understood. And I think the reason is that we're about exceptions and manual memory are about this far from being not really usable together. And so the C++ community to think very hard about what the rules are. It turns out that the language that they use is just as useful in C because it's the same thing, it's just there's less magic going on. But I want to point out to you that because of that, if you have used the language, like Python, for example, exceptions are so natural in the language that it uses an exception to stop iteration of a loop. Okay? So exceptions in Python are not even for exceptional conditions. as far as I can tell in Guido's mind, they're just a control structure you can use whenever. That's fine. The reason he can get away with that is that Python is so slow that the entire language runs at the speed of exceptions. So why not? Okay? Okay? The reason, I'm sorry, that's just true. The reason that the Java community does not take that attitude and they only use exceptions for real exceptions are because the Java virtual machine is much faster until you hit an exception and everything comes grinding to a halt, which is also the way it is in C++. It's just that, the slow languages, which is what I call them, the slow languages already run at the speed of exceptions. Why not? But the thing is, the difference is in Java, because you have garbage collection, mostly exceptions work. They also just mostly work in Python. They don't just work in C++, you have to know what you're doing. Now, I gave you about half the story, okay? It's doable, but I have to tell you, whenever I've interviewed with a company, I always use the C++, it's usually why I'm interviewing with them. I ask them, I always ask them, how do you subset? C++, this is a freebie, folks. If you come to C++ from other more sane languages, it's important to know that no human being has ever gotten away with using the entire language, so don't do it. Yes, it would make sense in Python, maybe in Java. Don't do it, okay? Just for the love of God. The point is that I always ask them, I'm really asking what subset do you use? I actually almost always get told they don't use exceptions, okay? So it's okay not to do that in C++, at which point you're doing it exactly the way I told you to do it in C, so you already know. You're welcome, and it's okay, even though all the cool kids on the net and the people who write books will sneer at you. I'm sorry, but industrial C++, in a lot of cases, they just don't use exceptions. And that's fine. Okay, it's also okay to use them if you've really learned how to do it, okay? Because the knowledge of, I'm about to show you something that I think came out of that community, the knowledge of how to use those right, it's actually useful everywhere else, it's just not necessary for absolute survival. The other point I want to make, exceptions in C++ retrofit very, very badly. And the reason is that if you didn't mean to use them, you probably have all of these functions which are in no way strongly exception safe, unless you did it exactly the way I told you to do it, in which case it'll retrofit fine. But otherwise, usually you start with a code base and you write it. You sometimes have to change an interface in order to make it exception safe in C++, which wouldn't be true, I think, in most languages. The point is that you just have to know what you're doing. Okay? Go ahead, Eric. Because we're basically done here, except I want to point out that even this, even as specialized as this piece of knowledge is to manually collected languages, actually you can take it with you. So let me ask you this. If you're programming in your nice, comfortable languages, you're programming in your website that's built in Python or Ruby, okay, if an exception is thrown, okay, memory won't leak. Tell me, what state is the website executing in? How many of you know for sure that if the exception was thrown, it rolled back the state and you know for sure? You don't know, do you? How many of you know? How many of you have written code in, a slow language, and a friendly slow language, where you know, for God's sake, for absolute certain, that it'll roll back? And you know this. You don't, because I've never seen anybody do this, and I started wondering, there's this weird thing, and I don't understand it because I like C, but I no longer like it with, C.S. Lewis said, you first love something, and you love it so much you don't see its faults, okay? She's kind of crabby, but you can't see it because you're in love. And then eventually you discover this, and it kind of, you sort of lose that love because you realize that, she's not all that and C's not all that. And then eventually you get to the final stage where you know where all the bodies are hidden. And it's okay. You still love her and you still like C, okay? And I'm kind of there with C, so I don't mind saying, I'm not enough of a fanboy to think this makes sense. The most reliable programs that I encounter typically are written in C, okay? And that doesn't mean that the average C program is more reliable than the average Python program. It means you take the most reliable ones. They tend to be the ones that actually just never shut down. The last big C job I did, my goal was that it could not be made to fail. That it was a fairly well-defined thing running on an embedded system, And that would never be the problem for the server, never. And I achieved that except when the server kept holding connections open. And the embedded system did not have timeouts in the C library, so I ended up having to implement polling myself, those kind of stuff. Anyway, the point is that most of the time, it seems to me, you know, the website that's written in a slow language, Perl, Python, Ruby, whatever you like, you know, maybe ops has to restart it every 2 or 3 months. No one knows why. I've come to the suspicion that part of the reason that this is so mysterious is because we haven't learned the very, very hard lesson that even in a very convenient language, which automates, you know, all of this grubby stuff, we still need to know. We still need to actually use transaction semantics, and we need to act, because otherwise, sooner or later, you know, very, very seldom, so we can never debug it, right? An exception is thrown that leaves something critical in a state it shouldn't be in. And now ops doesn't know why, and they say bad things about development, but of course development can't fix it, and ops has no idea why. This offends me because I have, you know, when I had to give up my religion of no go-to, I was sort of bereft of religion, and I sort of eventually adopted the religion that ops should never have to call me, because I'm too old to get up in the middle of the night anymore. So I should just write code that ops never calls me, and I would rather, you know, try to convince the boss that he needs to give me another week than to, or something. And I think this is part of it. So now, you probably write in the slow languages more than I do. So maybe you can, you know, maybe you can learn some more about it, but first you have to have the idea and go looking, because I think that has something to do with it. This is a lesson which comes out of C and C++ that's very painful there because you leak memory. But it's even more subtle, but I think it's still. So the point is that the other problem is once you learn this lesson, you need to get all your coworkers to do this, or pretty much it's still going to happen. Good luck. And with that, Eric, go ahead. And with that, just final thoughts because we're done. Okay, go ahead, Eric. And I see I went. Actually, okay, go ahead, Eric. All right, so here's our final thought. First of all, the germ of this talk was a few years ago. I remember talking over the web somewhere with somebody who was a Java programmer who was trying to learn C++. And I tried to help him, and it turned out the most useful thing I said to him was not what I thought would be useful. It was the point at which I said, oh, wait a minute, you're using the default. Don't ever use the default. And he goes, well, I thought it was probably there because that was the most common. He said, no, God, no, not in C++. It's never for you. None of the defaults in C++ are for you. They're for people in 1984 who have a giant C code base and want to evolve it incrementally. It's really there to take a code base written like I described in C and to gradually automate it with C++ so that you don't default to virtual functions, you default to non-virtual functions, because they're just what I showed you with sugar on them. And then later you start to evolve. They're not for you if you're doing new development, if you're learning it from Java. The most useful thing I did was to tell him, don't assume that the obvious appearance of the language has anything to do with how you should use it. That's true in C, but for different reasons. C wasn't designed to do that. It was just designed in the 70s. Okay? It was designed to write a different kind of code. This is the era when the function gets sounded like a good idea, right? Gets has no use case. Okay? Gets is a buffer overflow waiting to happen. Cannot be used correctly. But it was in the C library up until like the last version or something. Okay? People were very sporty about this. Okay? You know, I like to tell people, I like to tell younger programmers that, you know, we constructed Unix we were very conservative, a very elegant design. It was constructed out of a simple, universal data structure that can be used for every data structure, you know, just like closures can mimic almost everything else. The universal data structure was the buffer overflow. We constructed Unix entirely of buffer overflows. Well, I wish I were kidding more than I was. The point is that it is okay to use C. Do not feel bad about using C in ways it obviously wasn't intended, because it was probably intended to implement Unix with buffer overflows. okay? So just get over that right now. If you're gonna use C, and trust your brains and trust the fact that you're a programmer and you know stuff. You just have to get your feet on you in this strange world where you're exposed to a little bit more of the scariness of the machine. It's difficult, but it's not impossible. At least don't fear it. And now here's what I'm hoping is that the end of the horror movie where you thought the bad guy was killed, and then suddenly he shows up again, and then he's unmasked, and it turns out that was just a mask, and it's really one of your friends under there because he was he was playing a subtle game to beat the bad guy, and it's all okay. Here's a few of the things I didn't have time to cover. If you really want to get your feet under you, you probably should go and learn about these. I have lectured on these, but not. I won't do it here. The biggest one is something called undefined behavior. That's where he rips off the mask that is your buddy, the second mask, and he really is scary. Because the fact is that those terrible things, see, they've been read there. The dangerous things in C are not the things that, they're not the things that were sort of accidentally bad, or bad because we didn't know any better in 1970. They're things that were absolutely there by design, or still there by design. And undefined behavior is the scariest thing in programming, probably. But you can get quite far before you have to sort of really fight that. There are a whole bunch of very, very useful flags in the common compilers. Extremely useful. They work very hard to put them in them, and no one uses them because everyone thinks that WALL is good enough. Okay, if you're using WALL, you're phoning it in. You're just not trying. And I actually had a whole pile of slides once for a seminar on things you can do to make the compiler help you instead of always just flogging you and being your savage mistress. The other thing is that there are some debugging tools that you really, really want, and the most useful thing you'll ever find if you're using C is something called Valgrind. Okay? And the final thing is that there are some information security things I think everyone should know. Although a lot of it comes down to null all your memory before you free it. Okay? If you're doing anything that has secrets, you can get quite far with that. You may have to fight the compiler that tries to optimize everything. Okay, go ahead, Eric. And with that, we're done, although my wife, this last weekend we went to the JPL open house, mostly because I love, the exhibits are nice. I mostly like to go in the room where they actually have some of the researchers with the posters. And if I can get in there when it's not that crowded, I can buttonhole them, because a long time ago as a physicist, and I can, after about a few minutes, they'll tell me what I want to know and not what they prepared for the public. It's so much fun for me. I was talking in there with somebody, we started ending up talking about some of these things, and he pointed out that, we just can't my company really can't hire C and C++ programmers that program the kind of things I'm talking about. And my wife was very annoyed with me because I did not at that point saying that I would consider a position. So I guess she probably wants me to say that if you really like your code to look like this because it's more important to not have to fight it forever, then, maybe you want to talk to me. But anyway, go ahead, Eric. Then at least now I can tell her I did not entirely. Now with that, questions or, go to fires. There are some examples of how I lay out that exception pattern. It's kind of complex to explain. This was done on short enough notice. I didn't really have time to sort of put it on the screen, but I did have another talk that has both of those patterns illustrated, and that might be worthwhile. So anyway, with that, I'm done, and I'm going to quit talking unless you want to ask questions or whatever.
Otherwise standard C library functions have grown thread-safe versions. You have different names and have different ownership properties for the memory that gets allocated by them and stuff. Is there any kind of general statement you can make about those things? I mean-
On the whole, they tend to be safer to use, and part of the reason is that quite a few of them had static data in there, which is, sooner or later is always a deal with the devil. And so they had to basically quit doing that, so they tend to be, like reasonably re-entrant. And so generally they have a better interface, so I don't mind using them anyway. But, the whole issue of thread safety in Live-C, at some point you have to get out the list of things, guaranteed to be thread safe and protect everything else with a mutex or something. But yeah, the newer functions actually, as hard as I was on Live-C, there are so much code that depends on Live-C having exactly the errors that it has because everybody wrote to them. But that we can't change it. The committee does tend to put in things that are a little better. Not always enough better. I think one of the S functions actually bounds checked one of the inputs, but not the other one, so it was like, okay, half a loaf is better than none, I guess. But anyway, the thread safe ones tend to be better, have a better interface anyway.
Yeah, the first thought I had when you started talking about the memory allocation stuff is that Live-C is very inconsistent about the whole ownership notion.
I'm not sure of anything it's consistent about except causing pain. And I'm just telling you this because this was for people who actually have used languages. Look, we do learn as a community, and lots of languages have learned not to do the kinds of things we did in Live-C because it's painful. And so if you're used to languages that that didn't do that, Live-C is a rude shock. And yeah, it's very inconsistent. There's no doubt about it. And like I said, someday I usually wrap it in some way so that it fits the design, the architecture of my program. Someday, instead of having it always end up being part of somebody else's code, I'm going to actually just stick on GitHub a project where I wrap, every part of, Live-C is huge, but at least the parts that I need, as I go, they're going to be wrapped, they're going to be exactly the way I described it here, and they're going to just plug in, and that'll be nice, but I haven't done it. But wrapping Live-C, it would be nice if we could wrap it once, do it really well, and then try to get everyone to use it. It should go in the standard library, but C is almost as bad as Lisp is about, okay, we're done. We're not going to actually fix anything in the standard library. There are no containers in the C standard library. Anybody else? Yeah.
So is Rust the prophesied Messiah, or is there still reason to use C?
Yes, and it will be crucified momentarily. So here's the problem. C has the problem that it's good enough, and it's so critical to the stuff, to our infrastructure. You have to be a great deal better. And the problem is that while Rust is clearly a better design. Okay, it's the first time I've seen, at least in a language track, first time we've seen an advanced type system, okay, in the service of low-level programming where you care where the bits go. Because most of the people who write those type systems want to make sure that you have no idea that there are bits in there, right? Okay, consider this. Every machine, every virtual machine, every computer is a state machine. It is the entire story of the machine is about mutable state. The entire story about nature is about mutable state. There is no immutable state in nature. Okay? Even black holes can have their parameters altered. Haskell works very hard to make a virtual machine that has no mutable state. And that may be great. It's not, it's problematic for systems programming because systems are all about mutable state. Rust uses the same kind of type systems, but it is about mutable state. And for that reason, I think it's the first language that really would be, that we could use. You can write kernel modules in it. We really should just start writing our operating systems in something with at least the sophistication of Rust. The problem is, C is good enough to kill off every, so sometime go and look at how old crocodiles are. Turns out nothing ever gets into that little edge of the water riparian niche as a top level predator, because even if they're better, crocodiles are good enough and they eat them. And so actually they're older than dinosaurs. And C, I fear, has that quality. It's good enough to eat things. And so as much as I like Rust, and as much as I would dearly love someone to hire me to actually write industrial Rust and write code that doesn't leak memory because it compiled, I'm worried that we're just not going to do it because it's not enough better to deal with the fact that there are 1 billion crocodiles in the world, and they're doing pretty well.
What do you think the Redux OS?
I don't know the Redux OS.
It's basically an attempt to sort of reverse engineer the API of Unix in Rust as a kernel, and it's meant to be sort of a much lighter kernel and moving as much of the hardware management into user space as possible.
I'm sold. I've never heard of it, but I mean, that's kind of what we should do. The problem again is that the crocodiles were really, really successful, and they outlasted the dinosaurs. But that's the kind of thing, I mean, really, I'll tell you what's even more critical. We should just flatly insist that we're going to write our crypto code from now on in Rust. And the reason is that in crypto code, we really do care where the bits go. But C is really, really hard to write securely. I'm willing to do it, okay? But I'm not willing to let anybody else do it. Well, I mean, okay, so there are other people that can do it. Some that can do it better than me. But the point is that it's so it's hard to do. And so, if you want to give me a coworker, I would almost rather you give me a bright freshman or a bright grad than somebody that's been doing C for 20 years. Because the grad, I could probably mold him into somebody that maybe will do it to my standard. And I mean, I'm sorry that sounds arrogant, but I mean, it's really hard to do it in C. And I think that Rust is probably where we should write our crypto. The problem is, that, again, the crocodiles have outlasted the dinosaurs. I mean, if you remember the dinosaurs that C has outlasted, it's pretty impressive. How many of you are writing any, PL1 and Algol? Ada, absolutely. Ada is a prime example of a dinosaur. Yeah.
It's still used.
It is still used, but it is still used, but it's not.
dead.
It's not. But it's all. Well, languages take almost infinite amounts of time to die, but it's not spreading anywhere.
Yeah.
What's that?
Chickens after all.
Yeah, it's true. We do have chickens. Yeah, exactly. And what happens when the chicken meets the alligator and the crocodile gets it? Because they're indestructible. They're good enough to occupy this niche and prevent anything better from getting there. But anyway, no, I'm sold because that's what I want people to do. I just hadn't actually heard about it. But Rust is new enough that it's kind of fun because stuff pops up that you didn't know about. So it's kind of fun to have a systems language where they care where the bits go, but it kind of has that new cool kid feel because I haven't felt that since, actually I've never felt it. So. So is there another hand? Anybody else?
What language is Eric gonna learn first?
Okay, now, all right, so, forgive me, Father, for I have sinned. So let me tell you what I did. And then you will have to decide if you will absolve me and what penance you will require for my absolution. I would not have picked JavaScript, but let me tell you something. Khan Academy has the best programming environment, at least for his learning style, that has ever existed. I thought I had seen instant feedback before. Every time you type a letter, it tries to rerun it just in case you're done. And then the picture changes. And of course, it's graphics. The point is that the feedback is so instantaneous. And because you're drawing pictures, it's so much fun. And because, do you mind if I talk about you, Eric? Because his learning style is he wants to take something, he doesn't want me to explain things. You can tell I like to do that. He wants to fiddle with it. And if you want to fiddle with something, to get him to use other languages, you're going to have to be able to type a letter in the browser and it retries it. because it's that slick. So, he picked that, and he also, I said, well, maybe I should learn it with you, I'm not really a JavaScript programmer. He said, no! And I realized that he liked the fact that Daddy didn't know. So I took a strategic retreat, and I let him have that, to own that, and do it his way, so Daddy did not pick his first language. Yeah.
My daughter, she hates programming, but she took the Scratch. You know what Scratch
Yeah.
is?
I haven't used much, actually you use Scratch.
It's
you
on
did.
Raspberry Pi.
Yeah.
Scratch.
Is,
Okay.
is that that's a graphical programming
Yeah,
environment,
you
is
just
it?
splice this little thing that can make games.
Yeah. I'm not really qualified in that because I don't really like graphical environments. But the problem with that is I'm already a trained programmer. So my opinions don't really count here. And it does seem to work really
But
well.
I've seen kids really graphic.
Okay, so let me give you what I tried to do, and this may be useful for those of you with kids. I tried to take the same kind of advice. So in another life, galaxy far, far away, I actually, I'm licensed as a firearms instructor, although I didn't do much of it. But I do know a couple of things. And one of them is that the biggest mistake men make when they take their wives out shooting is they pick their wife out a gun. Because almost always he wants to go and she's going because he keeps asking. And then they pick her out a gun. If they're really stupid, they pick her out a little cute gun, which of course kicks a lot harder. And the point is that you can't do that. So when my wife wanted to learn to shoot, I took her to the Rahagis thing they do every June, because what they do is all the manufacturers come and bring their current models, and they set up on a firing line. You go up and you pay them, well, like $1 it's a shot. It's crazy, but the point is you're shooting their current line. You just walk to the back of the tent and you fire a few rounds. And I took her there, and I tried very hard not to editorialize about anything. And I just tried to have her shoot every reasonable self-defense caliber because that was her interest. And I tried not to editorialize because you can't pick that for somebody. And for Eric, at least, I realized I couldn't pick it for him, and that he was better off if I let him own it. So for some kids, at least, if they like Scratch, that's the best language. And that's not something that I can decide. So.
What year was this?
Sorry? Well, unless they've been doing it, they're usually every June-ish. So about now, I guess. There's like a kind of I don't know what to call it. There's an event out at the Rahagi shooting range where manufacturers will come and they'll bring their current line. They want you to shoot them and be excited about it. Unless they quit doing that, it was rather nice because.
Last weekend.
Was that last weekend? Okay. Yeah, I mean, the nice thing about it was that in the space of a couple of hours, she shot every sort of vaguely plausible well, okay, there are about 1 million plausible defense calibers if you're a reloader. But if you're not a gun guy and you're not a reloader, there are just a small handful. And she could shoot all of them. Yeah.
They have cannons too, to be fair. At the event they were talking about, they also have cannons.
They have cannons. Okay, so in fact, why am I here?
Yeah.
So yeah, cannons. That's pretty much all anybody ever needed, really.
Yeah.
And C, cannons and C. That's going to be the title of my now. I think I'll submit that talk to scale. Cannons and C.
Brass cannon.
But for programming languages, it might be the same. Maybe you have to I have to let Eric pick the language I wouldn't have picked because he owns it. And because he can be the expert and tell Daddy about it, and Daddy can't say, well, yeah. So it looks to me like people are kind of self-adjourning, so maybe we should head to the cars.
Okay, so if you guys park in the OpenX parking structure, make sure that you get validated. Also, somebody lost your ticket. 'Cause I have mine. So if you're missing your ticket, come up and claim it.